Alright guys, this week's lesson is timers. We use timers for all kinds of things. We use timers to turn off multiple things with the same run conditions. There are three basic types of timers. I'm going to go over those. Alright, we have three basic types of timers. We have a TON, which is a time on delay, and a TOF, time off delay, and an RTO, or attentive time on. First thing we're going to look at is a time on delay. Right here is the time on delay. This is what it's going to look like in your program. And whenever you add it to a rung, it's going to be on the far right side of the rung, just like your output instruction. And it'll say your timer on delay. Now the timer right here is where you're going to put your address. You're going to click that little box, and if you haven't used any timers before, you're going to use T4:0. And the time base is going to be in SLC 500s and in the RS Logix 500 processors. You get an option. Do you want to use 1 second? Do you want to use 1/10 of a second? And so on and so forth. But when you get to Studio 5000 or RS Logix 5000, you only get to choose milliseconds. So you'd put 5000 in to do 5 seconds. But in the 500 that we're looking at right now and talking about mainly, you get to choose, and most of the time I just leave it on 1 second, unless you want to break something down to half a second or something like that, then you can change that time base. The preset is how long do you want this thing to time. Let's say I wanted the timer to time for 1 minute and then turn on a light. My preset would be 60 seconds. I'd set it on 1 second, then put it on 60, and the accumulated value is when it's actually counting that accumulated value, that's going to be your live number. So if you set it for 60 seconds and it's counting, it may be up to 40, 41, 42. That's going to be your live count on your timer. The on delay timer has 3 bits to use within our program. Bit 13, or the done bit, can be addressed 2 different ways. This timer right here, we're calling it T40. Now remember, if we use another timer, a second timer in the program to do some other output or some other run condition, then it could be T4:1. And as you use them, the more you use them, you're just going to add another number to give it a different address. But we're addressing this one right here in this mock program, and it would be T4:0/13, or you can use T4:0/done. Most people prefer just to go ahead and type the DN in there, the done bit, rather than to try to remember which one's 13, which one's 14, which one's 15. The done bit will be set to 1 when the timer finishes its preset time count. So whenever the accumulated value equals the preset value, this done bit will come on. The enable bit we'll get to in a second, but it comes on when the run conditions go true. Another one we're going to talk about is the timer timing, bit 14, or timing bit. It's addressed as T4:0/14 or T40/timer timing. Alright, the timing bit is set to 1 only while the timer is counting. As soon as the time has expired, the bit will change to 0. So if we go up here and look, if this accumulated value is counting, it has not reached the preset yet, but it's counting, the timer timing bit will have a 1 in the bit box. That's how that'll work. Before it starts counting, or as soon as it gets done counting, it'll always be 0. The third bit we can use in a TON timer is the enable bit. It is addressed as T4:0/15 or T4:0/EN for enable. And it will come on, as I said earlier, as soon as the run conditions are true, the preceding run conditions. So it'll turn to a 1. And when it the preceding run conditions go false or we lose run continuity, the bit is set to 0. All right, now time off delay is similar to a time on delay, but it'll work just a little bit different. See, you got a time off delay. The timer will address the same way. If this is the first one you've used in this program, you're going to call it T4:0. If you use a second timer, you're going to label it T4:1, and so on and so forth. Start from 0 and work your way up. You could start at 10 if you wanted to, but I always like to start at 0 and work my way up. Time base works the same way as a TON timer. You can select 1 second, 1/10 of a second, milliseconds. Preset values the same way. How long do you want this thing to time for? Accumulated values the same way. It's the readout of the timing. All right, a TOF instruction is used much like a TON instruction. However, there's a big difference between the two. A TON instruction begins timing when its run goes true. A TOF instruction begins timing when the run goes false. So when the run is true and goes false, the done bit is set to 1. The timer timing bit, 14, is only set to 1 while the timer is counting. The enable bit, 15, is set to 1 when the run conditions become true and set back to 0 when the preceding run conditions go false. So if the run conditions go true, the enable bit is on and nothing else. Immediately when the run conditions go false, the timer timing bit and the done bit come on. Now the done bit will stay on even after you've reached your preset value, and the timer timing bit will go off when you reach your preset value. It's a little different to understand the TOF timer is, and in the next video I'm going to show you an example of how it works. All right, the third timer we're going to talk about is the RTO. It's a retentive timer. The retentive timer on instruction is programmed in the same manner as a TON and a TOF. It operates the same as the TON with one exception. If power is lost and restored, timing will resume where it's left off when power was lost. Here's an example. Suppose a timer had a time base of 1 second, a preset of 120 seconds, which is 2 minutes. And the power went off when the accumulated value had reached 60 seconds. When the power is restored, the timer will begin timing with 61. So a retentive timer maintains that time even when the power is lost. A retentive timer will also maintain that timer if the run condition goes false. So you don't have to lose power. If the run conditions goes false and it's on 60, it's going to remain at 60 until, when the run conditions go false, it's going to remain at 60. And when the run conditions go true again, it'll start counting again at 61. So when you go from, unlike a TON timer, the accumulated value does not reset when the run conditions go from true to false. An RTO timer can only be reset by an RES, or reset instruction, with the address set to the same address as the RTO timer.